Okay, hi everyone. My name is Susanna, and I'm going to be presenting on natural language processing with the natural library in Node. So first, what is natural language processing? It's a way for computers to analyze, understand, and derive meaning from human language. This is a field of artificial intelligence, so there are two parts to natural language processing. The first is natural language generation, and that's just translating a computer's artificial language into text. We can take this a step further by translating that text into audible speech with text-to-speech. Next is natural language understanding, and that's going to be a little bit harder because first, the computer has to take that natural language and convert it to computer language. Then it does speech recognition or speech to text. And once it's in the text form, natural language understanding can try to take a meaning or intent of that text. So it's a little bit harder than natural language generation. This is commonly used for things like automated question answering. So we have Siri, fighting spam in your email, and also machine translation, so something like Google Translate. So just to bring you back to like a brief history of natural language processing, it was first kind of written in the 1950s by Alan Turing, who's the father of computing. And he started off this book or this writing that he wrote, and he asks the question, can machines think? And this is what the Turing Test is named after, if you guys have ever heard of it. So what is the Turing Test? It's going to be a test of the machine's ability to exhibit intelligent behavior in a way that is similar to how a human can exhibit behavior. So the computer would be considered intelligent if it passes this test. And if you can see in the diagram, we have player A, and then player B, and then player C, which is the evaluator. So A is going to be a computer, but the computer is going to pretend to be a human and try to convince the evaluator that they are a human. And then B is going to be a real person, and C is going to communicate the text with the computer and the human and see if they can distinguish which one is the machine. If they can't distinguish which one is the machine, then that means that the machine has passed the Turing test and they would be considered an intelligent machine. So here is a picture of a computer studying for the Turing test. And also last year there was a movie, Ex Machina, where I don't know if anyone has ever watched it, but this guy, I don't want to do any spoilers, but this guy creates a artificially intelligent being. And this isn't like a very true example of what Alan Turing wanted in his Turing test, but this guy on the right, who's like I guess the main character, he tries to ask the questions to this robot lady, and the robot lady is very, very good, obviously. So yeah, no spoilers, but it's a really good movie. So we're going to discuss the natural library in Node.js. We're going to go over pluralizing and singularizing words, finding similarities in strings with string distance, classifying text with machine learning, and term frequency, so we can see how many times a specific word or a term is mentioned in a large body of text. So first is pluralizing and singularizing words using inflectors. And it's pretty easy to start using the natural library. All you have to do is npm install natural, and then you can require natural in your file. So I have an example with noun inflectors here, but there are also verb inflectors available. It's really awesome. So in this case, we're going to pluralize these words and singularize one word. So I have a demo here. Okay. Make this bigger. Yeah, so the file is going to be on the right, and you can see like that's the same thing I had in the slide, and I'm going to run this file in the terminal so we can see how the natural library works with inflectors. So once you do that, you can see it translates everything for you and gives you like the pluralized or singularized versions. Okay. Something else that the natural library can do is it can determine how similar two strings are. So in this example, this is the Jarrow-Winkler algorithm, and it's just one of the ways to determine string distance. There are other ones available like Levenstein, but Jarrow-Winkler is really good for short words. So say you had like a large project and you want to just make sure that all of the file names are matching up, like there could be a typo somewhere, it would be good to use Jarrow-Winkler. So it measures the distance by calculating how many matching characters the strings have, and then the distance within or distance from each other. So like in the first example, or in the top left, you see dynamo, and dynamo is 1, and that's because those are the same word. So it would give 1, and the least likely it is, it's going to be 0. So here is another example of what string distance would be. So you'll see I have 3 strings. I'm going to compare string 1 to string 2, so Grace Hopper and Grace Shopper, and then string 2 to string 3, which is Grace Shopper and Hummus. So you'll see like string 1 and string 2 are pretty similar. This is kind of obvious. And then in string 1 and string 2 and string 3 are going to be pretty different. So it has a 0.4 instead of a higher number. Okay. So that's just another look into that. And another thing that we can do is we can actually classify text into categories. So in the beginning I mentioned that this is very useful for things like spam. So automatically sending certain kind of messages into your spam inbox. In my example, I'm going to be doing what Google does, which is like social promotions or like shopping promotions. And we're going to train the computer to label based on subject line. So okay, so at the top you're going to see our training data. So you can probably put in as much as you want there. If you want the computer to be smarter, then you would have more training data. And the training data will take an array with text and labels. So I labeled certain things as promotions and certain things as something that should belong in my inbox. And then the test data is just going to be different examples of text that I want to see if like the computer is actually smart enough to put my things in the right box. And you'll see in my example that this one over here, getting started on Heroku, I guess that could be considered a promotion, but I wanted it to be in my inbox. And then I tried to figure out why the machine labeled it as a promotion, and it's because I think, so I have like a promotion where the word start is in it. And then I also have like confirm your account on Heroku. So it took that start and then decided that this would be a promotion instead of something that belongs in my inbox. So if you train your computer correctly, then it would label it correctly, hopefully. Okay, so the next thing is going to be term frequency, and this is going to be like in a large body of text, we're going to find if a certain word is mentioned. And in this example, I didn't do a large body of text, but you can see that I'm adding documents. So I have 4 documents added in, and one of them is, like it says, this document is about Node, this document is about Ruby. And then we can see based on this, the results of what, like if the word actually appears. Okay, so you'll see that I have I do find for Node, I find that Node does appear in document 1, document 3 and document 4, and it shows you like the number of times it appears. And then also for Ruby, you can see how many times that word appears. And this is using term frequency inverse document frequency. So that's another kind of algorithm that is good for like finding how many times a word appears. And the log, so this kind of shows you like how it's calculated. And the inverse document frequency is this very mathematical thing, and it kind of decreases the importance of common words like is, and the. Okay, so these are some of the resources that you can take a look into for the natural language library. The Egghead course is really, really good, and that's what I took a look at when I was learning it. So thank you.